Sorry. Okay, hello everyone. Today I will share you as a novel method for crowdsourced topic computation, which use a linear combination of rating and ranking tasks. And first, I will introduce the motivation of my works. And for example, if you want to recommend the top 100 movies on IMDb, we need to consider many factors. In general, we're considering 3 types of tasks. The first is the comparison task. For example, the worker should judge which one is better, the Shawshank Redemption or Forrest Gump. And the second one is a rating task. We will ask the worker to give a rating of the movies. And the third one is a ranking task. The worker should ranking given movies. Maybe he thinks the rank is Shawshank Redemption, Godfather, The Flight Club, and the Forrest Gump. And then for example, we all come to Houston to attend SIGMOD, and the steak in Houston is so famous. So you may be interested in the top 10 steakhouse in Houston in Yap. And when you encounter many bugs when you're programming, you may need to use Stack Overflow to find solutions. However, many solutions may be useless. So maybe you're only interested in the top 5 answers. However, this computation cannot be solved by computer only, because the computer don't know what's popular movie and what's delicious restaurant and what's useful solutions. To conclude, we will combine human resources and machine resources to compute the correct top key. So up to now, you may think it is very simple and easy. So what are the challenges? The first challenge is the monetary cost. For example, in real-world application, there are many crowdsourcing platforms, such as the Cloudflower. It is Figure 8 since 2017, and the Amazon Mechanical Turk. We also call it AMT for short. And our team, Tsinghua DB Group, also developed a Chinese crowdsourcing platform, www.chinacross.com. And as you can see, when you publish many crowdsourcing tasks on the crowdsourcing platform, it needs millions of crowdsourcing tasks with monetary cost. So as you can see, for rating tasks, comparison tasks, and ranking tasks, it's very expensive. So the second challenge is the noise from users. For example, someone who like action movie may think the Shawshank Redemption is so boring, but it is no doubt the Shawshank Redemption is the best film, is the best movie in IMDb. And maybe some women just don't like Morgan Freeman because of his bad behavior in the last month. So the third challenge is the data distribution. Because different real-world data sets has different distribution, which lead to difficulties when modeling. So based on such challenge, we aim to overcome such challenges. There are many state-of-the-art methods. The first type is pairwise only, and the second type is rating and pairwise, and the third is rank only. And our model is the first one to use a linear combination of rating and ranking tasks. In our work, the question assignment model publish both rating and ranking question to workers, and the question collection model collects answers from the crowdsourcing platform, and the manager will use machine learning method to give an inference of the top key results. First, I will introduce the detail of the inference algorithm. For rating task, we regard each object as a distribution, and each worker will give a rating of the object we infer the distribution according to the answers from different workers. Notice that different workers have different quality, so the answer have different confidence. If we consider rating task only, each movie is an object, then we find the distribution with the top k biggest probability. Let's consider a ranking task. Each worker will give a ranking results, and we will use learning to rank to find the results have minimum KT distance with all the users. A KT distance means the number of inverse pairs. Then we will use a linear combination of ranking and rating answers. We define a likelihood function for the linear model. Notice the tau. It is between 0 to 1. If the ranking answer is more reliable, the tau will be bigger. Otherwise, the tau will be smaller. And then we can use the gradient descent to update the parameter until converge. And then we introduce the selection algorithm. Look at the picture. The blue line is the ground truth, and the top blue line is the real top k. And the red curve is the inference results. In each iteration, we select question to minimize the gap between ground truth and the inference results. But as you can see, it needs too many questions. So we notice that we have two types of misplacing errors. The first is false positive. The second is false negative. In each iteration, we select objects which are most likely to be misplaces. Also, our method can be extended to support other distributions, maybe a Gaussian distribution or skewed Bell distribution or long-tailed distribution, such as ZIP-F distribution. And also, our method can prevent attack from spammers and ignore the answers from workers with low quality. And in the future, we will extend our work with commands and photos to compute crowd-top-k. For example, in the YAP, there are many photos from the web users and commands from web users. We will integrate these results to compute the crowd-top-k. And we will extend our work to support spatial crowd-top-k computations. Thank you for your listening. Any questions?
Can the next speaker come over to get the thing set up? And we have a couple of minutes for questions. No? Okay, then that's helpful for us to. Okay.
So your method combines the ranking and the rating as the input. So how do you compare with your method with other competitors in terms of the human causes? Because for different type of inputs, you may have different costs, right? So how can you compare your method with those pairwise-based solutions?
We use four data sets. The first one is the movie's publishment time. And the second one is IMDb rating and blah blah. So we will use our method and collect the maybe collect the top 10 results and compute the recall and compare the evaluation with other methods.
So does it cost more or less than the competitors?
Yeah, for different type of questions, you pay differently, right? To the worker. So do you consider this in the experiments?
Yeah, I consider it.
Yes, the cost of comparison is the same as the cost of reading. But the rating gets lower, the same as the pairwise comparison.
But I think
ranking, the cost is larger, so we pay more for the ranking.
okay.
Let's thank the speaker again.